Solving 3x3 word problems. A box of wood contains wood. Well, that's redundant. Solving 3x3 word problems. A box of wood contains wood cut into triangular, square, and pentagonal shapes. There are 80 pieces of wood in the box, and the pieces have a total of 290 sides. If there are 10 more triangular pieces than square pieces, find the number of pieces of wood of each shape in the box. Okay, so you want to find your x, y, and z, and we'll just use triangles for x, squares for y, and pentagons for z. Then the next step, you want to make your equations. So here it says there are 80 pieces of wood in the box, so that would mean that all the triangles plus all the squares plus all the pentagons would equal 80. So x plus y plus z equals 80. Then it says, and the pieces have a total of 290 sides. Well, a triangle has 3 sides, a square has 4 sides, and a pentagon has 5 sides. So 3 sides for each triangle, 4 sides for each square, plus 5 sides for each pentagon equals 290 sides. Now, if there are 10 more triangular pieces than square pieces, find the number of pieces of wood of each shape in the box. So there's 10 more triangular pieces. So for x to equal y, there would have to be 10 fewer triangles for there to be the same amount of triangles as pentagons. So x minus 10 equals y. So now you want to solve for a variable, and y is already solved for, so you can just use y equals x minus 10. And now you want to substitute this into the other two equations. So x plus x minus 10 plus z equals 80, so we just replaced y with x minus 10. And then to simplify this, you would just add 10 to both sides and then combine like terms, the two x's. So you get 2x plus z equals 90. Now the next step would be to substitute, again, x minus 10 in for y in the other equation. So 3x plus 4 times x minus 10 plus 5z equals 290. And again, you're just replacing the y with x minus 10. And so then you want to simplify this by distributing the 4 into everything inside the parentheses. So 4x minus 40. And then you combine like terms and you'd add 40 to the other side. And so adding 40 to the other side would give you 330, and 3x and 4x combined together to be 7, and the 5 just stays the same. And so now you're left with the 2 by 2, the highlighted equations. And so here, negative 5 times 2x plus z equals 90 times negative 5. The reason why the negative 5s are on the outsides here is because you're trying to make it so that you can, we're solving this equation by elimination. So we chose the z, and we're going to multiply it by negative 5 so that it cancels out with this positive 5z. So you just multiply the entire top equation by negative 5. And when you get that, you get negative 10x minus 5z equals negative 450. And then because you're using elimination, these cancel out, and these combine, and these combine, and you get negative 3x equals negative 120. And then you divide by negative 3, and you get x equals 40. So now you can plug in x to find the other variable. So 7 times 40, which would have been x. So 7 times 40 plus 5z equals 330. 7 times 40 is 280, plus 5z equals 330. You subtract 280 from both sides, and you get 5z equals 50. Divide by 5, and you get z equals 10. So then you can plug in your x and your z to find your y. And the easiest one to solve for is probably this top one. So x plus y plus z equals 80. You just replace the x and the z with the values that you have. And so you get 40 plus y plus 10 equals 80. You would subtract 50 on both sides because the 40 and the 10 combine to be 50. And you get y equals 30. So now you have your x, your y, and your z. Your triangles, x, you have 40 triangles. Your squares, y, 30. and you have 10 pentagons, which was your z. So now you just want to put it into your ordered here alphabetically. So x, y, and z, 40, 30, and 10. All right, the second problem, a change machine contains nickels, dimes, and quarters. There are 75 coins in the machine, and the value of the coins is 725. If there are 5 times as many nickels as dimes, find the number of coins of each type in the machine. So the first step would be to just set a variable to each one, x, y, and z, and it's easier to do this if you do it in the order that it's read in the equation. So for the equations that you get from these, well, it says there are 75 coins in the machine, meaning all the coins together would equal 75. So x plus y plus z equals 75. And it says the value of the coins is 725. So just like the amount of sides on the last problem, you're going to assign a value for how much the coin is worth on this one. So a nickel would be 5 cents, which is also 0.05. It's easier to write it out like that. So okay, so just like on the last problem with the sides of all the different shapes, you're going to assign the values to each of these. So a nickel would be 5 cents, a dime would be 10 cents, and a quarter would be 25 cents. And those all combined together would be $7.25. So that's how you get that equation, just based off of the money value of all the different coins. And then x equals 5y. There's 5 as many times, or there's 5 as many nickels as dimes. So the dimes, there would have to be 5 times as many dimes to equal the nickels. So x equals 5y. And so now you want to solve for a variable. Of course, this one's already solved for you. So x equals 5y. And then you just substitute in 5y into these other equations for x. So 5y plus z equals 75. And you combine the like terms, you get 6y plus z equals 75. Now you want to plug in, again, 5y for x in the second equation here. So 0.05 times 5y plus 0.1y plus 0.25z equals 725. And you just substitute in 5y. So now 0.05 times 5 is 0.25. So 0.25y plus 0.1y plus 0.25z equals 7.25. And then your y's, you combine them together. So make sure you don't accidentally add this to the hundredths place. You want to add that since it's in the tenths place. So 0.35y plus 0.25z equals 7.25. And then you're left with a 2x2 now, so you can solve that. And so this one, 6y plus z equals 75, is the one that we're going to match up with the second equation we got, because this is all decimals, so it'd be a little bit more tricky to use for elimination. You could also use substitution to solve this 2x2, but as long as you could just multiply this by 4, because 0.25 times 4 would be 1. So, and you also need it to be a -1, so 0.25 times -4 would make the z's cancel out. So, because you would result in a -z. So you're going to multiply the equation by -4. So -1.4y is what you get when you multiply -4 times 0.35. So -1.4y minus z, and again the z times the 0.25 times -4 gives you the -z, sorry. And then 7.25 times -4 is -29. So 6y plus z equals 75. Again, that's just that original one. And then you combine them together. The z's cancel out, and -29 and 75 combine together to be 46. and negative 1.4y combines with 6y to be 4.6y. Then when you divide 46 divided by 4.6, you get y equals 10. So now you can plug in y to solve for z. So you can just use this top equation up here, any one that has just the y's and the z's for the variables in it. So you plug in y for 10, so or 10 for y, and 6 times 10 plus z equals 75. So then you get 60 plus z equals 75, and then you get z equals 15, because you just subtract the 60. So now you can use y and z to both together in one of these equations to solve for x. So x plus 10 plus 15, you're just substituting in your y and your z, equals 75. So x plus 25, when these combine together, equals 75. And then you'd subtract 25 from both sides and you get x equals 50. So you've successfully solved this equation. You get all your x, y, and z values. Nickels, you have 50 nickels. Dimes, you have 10. And quarters, you have 15. And so then you put them in alphabetically, and x, y, and z, 50, 10, and 15.